Good afternoon, everybody. Now let us start our class. So, in my last class, I already told you the theorem which is related to the sufficient condition for differentiability. So now we'll come to an example. Okay. So now consider an example. This is lecture 2. Okay. Now consider an example which is related to this sufficient part of this differentiability. So let your f of z is equal to, or let a f of z is given by e to the power x whole into cos y plus I sin y, cos y plus I sin y. So so that it is differentiable everywhere in C. So that this f of z is differentiable everywhere in C. That means in whole complex number. Okay. So here f of z is given by, here f of z is equal to e to the power x whole into cos y plus I sin y. Okay. So what is your u of xy and v of xy? That this thing is your u of xy plus I times v of xy. So your u of xy is e to the power x whole into cos y, and your v of xy is e to the power x sin y. Okay. So this is your u and v. Then what will be your ux or ux at xy? Just take its partial derivative with respect to x. Then e to the power x derivative is the derivative of e to the power with respect to x is e to the power x, and cos y remains as like, that means this can behave as a constant. So ux is this one, then uy. Then take its partial derivative with respect to y, then e to the power x will like a constant, or this thing is stated as a constant. Then derivative of cos y is minus sin y. So this is minus of e to the power x sin y. Similarly, v of xy is this one. Then what is your vx of xy? And vx is, take the partial derivative with respect to x of e to the power x. Again, this will be e to the power x, and sin y will as like it is. Then what is your vy? Then vy will be e to the power x into derivative of sin y is cos y. So if I will say, here you can notice that your ux is equal to vy e to the power x cos y. This is e to the power x cos y. So ux equal to vy, and uy equal to your minus vx. So uy, which is your minus e to the power x sin y, and this is e to the power x sin y. So uy is your minus vx. Thus Shear equations are satisfying for all xy, and the u of xy, v of xy, and all its partial derivatives, all its partial derivatives are continuous. All its partial derivatives are continuous at any point xy. And this is the first condition, and this is the uxy, vxy, and all its partial derivatives are continuous at any point xy. This is the second condition. So since these two conditions are satisfied, hence you can say f of j is differentiable in whole. Okay. See here, this is u of xy, v of xy, and this is your ux, uy, then vx, vy, all these things are continuous at xy, because all these things are product of exponential and trigonometric, and you know exponential is continuous and this trigonometric is continuous, so their product is again a continuous function. Okay, so this thing holds. So now come to another thing, which is the alternate form of Shear equations, or you can say this is complex form of there are alternate form of Shear equations. Alternate forms of Shear equations. So first I will say one thing. This is complex form of Shear equation. So there are two theorems. First one is the complex form of Shear equations. Complex form of Shear equations. So what is the statement? Let f of z, let f of z, let f of z, which is equal to your u of xy plus I times v of xy, be differentiable, be differentiable in C. Then shear equations in complex form. Then shear equation can be put. Then shear equations can be put in the complex form. Can be put in the complex form as f of x is equal to minus I times f of y. Okay, so this is the complex form of shear equations. Okay, or shear equations can be put in this complex form. Now I will prove it. Okay, so given that f of z, which is u of xy plus I times v of xy, is differentiable in C. So it is given that f of z is u of xy plus I times v of xy. This thing is differentiable. This thing is differentiable. Okay, so if this thing is differentiable, so your f of z is this thing. So what will be your f of x? So f of x will be your ux plus ivx, and what is your f of y? F of y means the partial derivative of f with respect to y. Then this thing can be written as this is uy plus I times vy. So now consider this f of x. Consider this f of x equal to minus I times f of y. So your f of x is u plus ivx, which is equal to minus I times, and f of y is your uy plus I times vy. So if I will multiply this minus I, then this will be minus I times uy plus I square is minus 1, then again another minus 1. So this is plus vy. So I can write this is vy plus I times minus uy. So if you compare these two things, because this thing is equal to this thing, so real part is equal to real part and imaginary part is equal to imaginary part. So you can continue this thing. This is ux plus ivx. This is ux plus ivx. So real part will be equal to real part and imaginary part will be equal to imaginary part. So ux is equal to vy and your vx is equal to minus uy, or uy equal to minus vx. And you know this is your shear equations. So if this thing is given, then you are getting the shear equations, and if shear equations is given to you, then you can come to this thing. So this is the complex form of shear equations. And this is complex form because the I stands here. That's why we can say this is a complex form of shear equations. Okay, now this thing proved. Now comes to shear equations in polar coordinate. This is another form of shear equation. So shear equations in polar coordinate. Shear equations in polar coordinate. Okay. So what is the so let f of z is equal to let f of z, which is equal to u of r theta plus I times v of r theta be differentiable at z. This thing be differentiable. This thing be differentiable at z. Z means r e to the power I theta. This is the z in polar form. That is the answer. Then, so f of z is when it is differentiable at z, then we have to show this u r equal to 1 by r v theta and v r minus 1 by r u theta. Okay, so this is the shear equation. Then further, your f dash z can be written as this is r by z whole into ur plus ivr, ur plus ivr. Okay, so if f of z in polar form, if this thing is differentiable, then it is 0, then ur equal to 1 by r v theta and vr equal to minus 1 by r u theta, and f dash z will be this thing, and we have to prove this thing. Okay, so in given that for this, given that if z is equal to u of r theta I v of r theta, this thing is differentiable at any point z with r e to the power I theta. This is not non-zero. So now let x is equal to r cos x equal to r cos theta and y equal to r sin theta. So now my or what is this is del u by del r, this is your u, and ur is the derivative of u with respect to r, and we know u is a function of r theta and each r theta is a function of xy, so we can write ur is equal to del u by del x by del r. Okay, then del sorry then this is del u by del y, del u by del y, then del y by del r. Okay, so here x equal to this one and y equal to this one, so del x, and what is your del x by del r? This will be cos theta. Similarly, this is del u by del y, and this one u by del r is your sin theta. So this is your del u by del r, or this is u r. Then what is v theta and v theta, which is del v by del theta, and del v by del theta can written as this is del v by x by theta and del v by del y, and this is del y by theta, and this is del v by del x, and del x by del theta x is equal to this one, then del x by del theta equal to r, and derivative of cos theta is minus sin theta, so this is minus r sin theta, then del v by del y, and del y by del theta, y equal to this one, so del y by del theta is r. So now 1 by r into del v by del theta, so del v by del theta is this one, then 1 by r into del v by del theta, so now dividing r, this will be del v by del x minus del v by del y cos theta. Okay, so now applying shear equations here. So what will happen if we will apply shear equations? So we know shear equations. We know shear equations are u. We know shear equations are u is equal to vy and u equal to minus vx. So in place of vx, In place of Vx, I will put minus Uy. So this is minus Uy minus del Uy of sin theta, and there is an minus also here, so it will be plus. So del U by del y sin theta, and del v by del y is the ux. So this is del U by del x, del U by del x cos theta, and you see this is this thing, del U by del x cos theta, del U by del x cos theta, del U by del x sin theta, del U by del y sin theta. So this is your del U by del r. This thing is your del U. This is your ur. So this is your ur, and here this is 1 by r here. So we got our first relation. This is ur 1 by r. So this is v theta. So ur equal to 1 by r v theta. Okay. Similarly, we can prove the second relation. Similarly, we can prove. That Vr equal to minus 1 by r u theta. Now we'll see the next thing. The f dash z equal to, so f dash z is equal to r by z whole into ur plus I v r. Okay. So now consider. Now our aim is to prove that thing. Consider r into ur plus I v r. So this is r, and what is your ur plus I v r? And your ur means this is del u by del x by del x, then del u by del y, and this is del y by del r, and this is your ur. Similarly, then I times, then I times what is your vr? Then this will be del v by del x by del r plus del v by del y, then del y by del r. Okay. So now this thing is your r times what is your del u by del s? Let it be as del u by del s. Okay. So del x by del r, we know our x is equal to cos is equal to r sin theta. What will be your del x by del r? This will be simply cos theta by del y. Then what is del y by del r? Y is this one, so del y by del r is your sin theta. Okay. So let it be in curly bracket. Then I times, then this is del v by del x. It is del x by del r. This is simply cos theta. Then this is del v by del y. Again del y by del r is sin theta. Okay. So r times these things. Then if we will combine r cos theta, so r is common from this whole thing. Then this is cos theta, and this is cos theta. So what you will get? This is r cos theta taking common. This is del x. Then this is I times del v by del x. Okay. Again taking sin theta common, r sin theta. After taking r sin theta common, then this will be del u by del y, del u by, there is sin theta again. This is I times del v by del y. So next what we will do? This is r cos theta. This is your x. R cos theta is your x, and r sin theta is your y. So I will put this thing. So this is x whole into del u by del x plus I times del v by del x. and this is r sin theta. I can add this one as y, and again I will use the CR equations. So if I use the CR equations, what will be your uy? You know our CR equations is ux is equal to vy and uy equal to minus vx. So in place of uy, I will put minus vx. So this is minus del by del x plus times, and your del v by del y. This is your uy. This will be your ux. Del u by del x. So this will be x times del u by del x plus I times del v del by del x, and here you can take I as common, so that it will be I. So you can take I common, then first I will add this one. This will be your del u by del x plus, and this is minus 1 means, if you will minus 1 means, you know minus 1 means this. So if one I will go common, then this will be I times del v by del x. And you know this thing f dash z is ux plus I. So I can replace these two things by f dash z. So this is x times f dash z plus iy times f dash z. So this will be x plus iy times, then x times iy means this is your z f dash z. So what we got, this is your r times r plus r is this one. So r by z, if I will divide z in both sides, so r by z whole into ur plus ivr, this is your f dash z. So this implies we got r by z whole into ur. So if your f of z is given in polar form, formula how to find its derivative. Okay. So again now comes to now this thing is proved. The above theorem is proved. Okay. So now comes to next thing. There is another small theorem. Let f of z be a differential function, or let f of z is a differentiable function. The shear equations can be put. The shear equations can be put in the form del f by del z bar equal to 0. Okay. So now we'll prove it. Given that f of z is a differential function, then shear equations can be written in this form. So if I will consider del f by del z bar, okay. So del f by del z bar, this thing can be written as del f by del x by del z bar, del f by del y by del z bar. Okay. So what will be your del z by del x by del z bar and del y by del z bar? We know what z is equal to x plus iy. So z bar is your x minus iy. So z plus z bar divided by 2. This is your x, and your y is z minus z bar divided by 2i. Okay. So this thing can be written as del x. So del x del z bar, x is your this one. So del x by del z bar, this will be your half. Similarly, del y by del z bar, this will be your minus 1 by 2i. Now if I multiply I on both numerator and denominator, this will be minus I by 2i square, and I square is minus 1, so this will be I by 2. Okay? So del f by del x into plus del f by del y I by 2. Okay, so if I will take my plus of x by plus I times, and now just we know the complex form of CR equations, which is fx equal to minus I times fy. So we can say left by divided by this thing equal to 0. If this thing equal to 0, so if this thing equal to 0, left equal to minus I times del f by del y, which is the complex form of CR equations, because we already proved here on the starting. This one fx equal to minus I times f of y. This is the complex form of CR equation. So 0 implies del f by del x equal to minus I times del f by del y. So this thing equal to 0 if and only this these two things are equal, which is your complex form of CR, which is complex form of CR equations. So this implies this thing. So hence CR equations can be put in the form del f by del z bar equal to 0. Now come to a problem that f of z, which is written z real z divided by mod z. This if z is not equal to 0, and this f of z is equal to 0 if z is equal to 0. This continues at z is equal to 0, but not differentiable at z equal to 0. And you have to show it is continuous at origin but not differentiable at origin. So now continuity, if the limiting z goes to 0, f of z